This video is going to be on how to find the lowest common denominator, also known as the LCD. So let's say, for example, that I am looking to add 5/18 plus 7 over 36 plus 3 over 40 plus 13 over 150. Then we know that we need to find the LCD because we're adding fractions. And the same is true for subtracting fractions. When the numbers are really small, though, many of us just do it in our head. But when our numbers get a little bigger like this, sometimes it's not quite so obvious what the LCD of 18, 36, 40, and 50 would be. So the best way to approach this is to actually break down all of your denominators into their prime factors. So let's start with 18. So 18, I'm going to do the factor tree. So what goes into 18? Well, 9 times 2 is 18, and 3 times 3 is 9. So that means that 18 is equal to 2 times 3 times 3. And let's do the same for 36. 36, let's see, 6 times 6 is 36, and for both 6's we get that 3 times 2 is equal to 6. So then we get that 36 is equal to 2 times 2 times 3 times 3. And next up is 40. 40, 10 times 4. 10 is 5 times 2. And 4 is 2 times 2. So 40 is equal to 2 times 2 times 2 times 5. And lastly, we've got 150. Let's see, 15 and 10. 10 is 5 and 2. 15 is 3 and 5. So then we have that 150 is equal to 2 times 3 times 5 times 5. Okay, so here we have all four numbers broken down into their prime factorizations. Now, the next question becomes, well, first of all, notice that I listed the numbers like from smallest to biggest. So 2 times the 2's and then the 3's, the 2's and then the 3's. And the most important thing is that you just group all the same primes together. So all the 2's are together, all the 3's are together, all of the 5's are together. Now, by definition, LCD is really the least common multiple between the four denominators, right? Well, what does it mean to be a least common multiple? Well, that means I'm looking for the smallest number such that 8 times something is equal to the LCD, 36 times something equals the LCD, and so on and so forth for 40 and 150. So I want the LCD to be a multiple of all four numbers. Well, the benefit to breaking it down into its prime factors is that this tells me exactly what makes up my numbers. So for example, if I look at 18, 2 times 3 times 3, I can multiply the 18 by anything in the world, and that would be, the result would be a multiple of 18. So I can see that I know that in order for something to be a multiple of 18, it must have a 2, a times 3, and a times 3 involved. And if in order to be a multiple of 150, I must have 2 times 3 times 5 times 5 somewhere in the prime factorization. So I'm going to find the way that all of those needed numbers are represented in my LCD. So the way I do that is I look at how many times any given prime shows up, and the most amount of times. So how many 2's? Well, 18 has 1 2, 36 has 2 2's, 40 has 3 2's, and 150 has 1 2. The most 2's that ever appear are 3. So I'm going to underline or circle or box or whatever, somehow indicate that I need 3 2's, because that's the most amount of 2's that appear. For 18, I need 1 2 for the LCD to actually be a multiple of 18. Well, that 1, 2 is accounted for when I say I have 3 2's. So that's why this works. Okay, how many 3's? Well, 3 3's over here, 2 3's, and 1 3. So the most amount of 3's that appear is 2. Now, 36 also has 3 3's, but I don't need to underline those ones. I just need to make sure that the most amount of times a 3 appears in any given number is accounted for. So when I say 3 3's right here, these 2 3's are accounted for in there, as is this 1 3. So I don't need to underline these ones. I just need to underline one of the pairs. All right, what's my next prime? 5. Well, 18 and 36 don't have any 5's. 40 has 1 and 150 has 2. So 150 has 2 5's. And those are the end of my primes. So I would do this with all of my primes regardless of how many that I had. Sometimes it only appears once too, and that's okay. Just in this example, they all appear 2 or 3 times. So my LCD then becomes all of my underlined numbers. 2 times 2 times 2 times 3 times 3 times 5 times 5. And that turns out to be 1800. I'll leave it up to you to verify. But now here comes the next hard part. The next part is, okay, now that I know that my LCD is 1800, in this case that's I mean fairly big, right? I need to decide what do I need to multiply all of these numbers by to get my LCD. Now that you've already done this work, it turns out that there's actually a very nice trick to making that really easy. So I'm going to write down my LCD up here in its primes. 2 times 2 times 2 times 3 times 3 times 5 times 5. And here's what I'm going to do. Let's get a new color. I know that 2 times 3 times 3 is responsible for being 18. So if I take away 1 2 and 2 3's, those altogether are equal to 18. So what's left over is what I need to get 1800. So if I do 2 times 2 times 5 times 5, that should give me what I need to multiply 18 by to get 1800. And let's see, that's 2 times 2 is 4, 5 times 5 is 25, and 4 times 25 is going to equal 100. So I need to multiply, and this one I know you could have done in your head. I mean, everybody knows that 100 times 18 is going to give us 1800. But I wanted you to see the process because not all of them are so easy. For example, do you know what to multiply 36 by to get 1800? That one's a little bit not so obvious. But so far up here, it was 100. Now, do this for every single one here. So 2 times 2 times 2. And you don't always have to write it down. If you can do this process in your head and cross things out, then that works. But I really want to be explicit here. So 2 times 2 times 3 times 3. I'm left over with 2 times 5 times 5. So 25 times 5, which is going to be 50. So you have to multiply the top and bottom of this one by 50 to get 1800. And write it again. 2 times 2 times 2 times 3 times 3 times 5 times 5. And we've got 2 times 2 times 2 times 5. That leaves us with 3 times 3 times 5. And that gives us 9 times 5, which is 45. So multiply the top and bottom by 45. And lastly, we've got 150. So 2 times 2 times 2 times 3 times 3 times 5 times 5. And we've got 2 times 3 times 5 times 5, leaving us with 2 times 2 times 3, which is 4 times 3, which is 12. So this one needs to be multiplied on the top and bottom by 12. And now I would just go through my work from there. But this is always the hard part when it comes to to doing addition and subtraction of fractions where we need to find the LCD. So there we go. I hope that trick really helps you out.